Alrighty, so today we're going to show you Deformers and Maya. These are basically tools that help modify how your mesh looks. Now there's different types of deformers you can add onto your model, but today we're using the nonlinear deformers, which are the most automatic of the bunch. We're going to get into lattices later, um, but this is the bend tool, and basically how it works is that you go to bend, and you can change the curvature, and that mesh will follow that curvature. You can change the low bound, the high bound. So if I put on the mesh, you can see that it bends like that. You can change the low bound to 0, and the mesh on the bottom will stay perfectly still. You can actually change the position of the bend handle, and the mesh will act differently to it. So if you put it up there, it's going to wiggle only a little bit on the top. Go down there, it's going to go nuts. You can change the rotation of the bend, so you can have it go back and forth if you just rotate to 90 degrees. And yeah, you can have it like sweeping. Sort of like a animated Disney film. Fantasia. So, I'm trying to keyframe it. Give you an example of what it'll look like. All right, that's one example of how to handle your bend deformers. You can make nice, simple animations with this. Okay, next one is flare. Basically how this works is that you have two different axes, the X and the Z axis. And basically you can change the formation of the two, so you can make the circles wider or just plain bigger or taller. What you can do is curve those flares and inflate them. So if I get the broom out, this will become super wide, super long. It'll make the broom a lot thicker, it'll become an unusual size. Then you can just make it look more bulgy, or you can even invert it. You can do some serious cartoon effects with this. All right, next tool, I think we're ready to go. So let me just delete flare. The sine tool, if you're familiar with sine waves in trigonometry or math, this is basically the same thing. You can make it all wobbly, like a sine wave. You can change the wavelength, so you can have it like super small. You can change you can say you're changing the frequency of the model. That was a bad joke. So yeah, you can change the wavelength depending on how many quads you have. If it's like super high poly, it'll probably be able to make that effect. If not, it's probably going to look like that. So you can change the low bound, the high bound, and change the amplitude. And yeah, that's pretty much it. There's also an offset if you want it to like wiggle. It's kind of funny looking, but let's do some keyframe animation here. I'm just having fun with this. Whee! Yeah, so there's a lot you can do. All right, next up, squash. Like squash and stretch. This is very similar to that. Change the factor of the squash and stretch. You can expand the model if you like. So you can see there's the little circle that controls the expansion. The little locators on the top and the bottom are basically the limits of how much is being squashed and stretched. So like you can like animate a ball with this if you like. Then there's twist. Yeah, so you can basically just twist the model, give it a little spiral-esque, helix-esque form to it. If you were to do modeling with this specific deformer, you'll probably be doing like rope or like different shapes of pasta, probably. Um, I don't know what type of things you can really model with the twist deformer. But it's good for like little animations. You can have like the broom looking from the side to side. Now we have the last one, wave. Basically, just similar to like the sine wave a little bit. In fact, it's probably just pretty much similar. Since you got amplitude, wavelength, offset, drop off. Yeah, there's not really much to say about this specific deformer, but yeah, that's pretty much it for all the nonlinear deformer examples. We'll go over the lattice tool, which is more of a more customizable deformer, so I'll show you that next time.